about it. No? That was
Lawrence
Mr.
likes it.
Tank's staple. I think
Lawrence
when he
Oh,
was
it's
a
like
kid.
we're all going. Who's never had it?
He liked the what
all the
spaghettios and meatballs.
Fire. Spaghettios are so good.
Never had
Yeah.
spaghettios in my life.
Wow. Wow.
We should maybe buy a bunch and make some.
Look,
Just
I'm
have a
also-
class party. You guys think I will come
I'll
this fall?
almost-
At this point, I'm gonna ask you better eat cereal.
Do you don't eat cereal?
No. I just, I wouldn't be
I
surprised if
I
I didn't
literally
eat
had
cereal.
Reese's Puffs today. And
It's just weird.
Alright, so let's look at the first one. Can you use synthetic division for number 1? Anybody say yes?
Oh, I used to.
How did you use
Oh,
synthetic
it's
division, Josh?
2/3, like I said, 3x.
Yeah, so as long as your divisor, this guy here, as long as it's linear, you can divide. So he said he set it equal to 0, and he got 2/3. So that's what you're dividing with. You can divide with 2/3. Yes, long division works. Long division works for everything. Like the quadratic formula works for any quadratic function. Long division works for any polynomial if you're asked to divide. But you can also use synthetic division if whatever you're dividing by, the divisor is linear. So if you're using synthetic division, we're dividing with 2/3. So Josh, since you did this with synthetic division, what is 2/3 times 48?
32.
32. So you get a nice number there.
That's good.
And then when you combine negative 80 and 32, that makes,
48.
so then 2/3 times negative 48, Josh, is
It's -72.
negative 72. Where?
Wait, hold up. Give me a second. Give me a second. -32.
Okay.
That's what I meant to say.
Wait, yeah. And then 41 minus 32 is,
That would be. See, now you got me all messed up. 9.
okay, I'm sorry.
You're okay.
And then finally 2/3 times 9 is,
Me again.
yeah,
Okay.
yeah, I mean, you're just doing so well, so.
Yeah. That's not mean. Okay, 6.
No. And the remainder is
0.
0.
0.
So you get a remainder of 0.
Right.
So the remainder of 0 means this guy here is a factor, or this is an x-intercept, a 0, a solution. Your resulting polynomial, we divided with 3x minus 2, no matter which way you did it. And we got 48x squared minus 48x plus 9. So no matter which way you did the division, you should have still got the same answer. So who did long division? Did you get the same answer?
Yeah.
Yes. So even if you did long division, you should still get the same quotient. Yeah.
I did not.
You did not get that. Did you do long division? Yes. Oh, I think we can take a GCF out. And then you would have the same thing. Yes. So it looks like we could take a GCF out of 3 and then you'd get 16x squared minus 16x plus 9. Yes. So if we pulled our GCF out, then you would have the same value. Questions? So then number 2, why must you use long division with number 2? So Dylan, why do you have to use long division with number 2?
Because of the x squared.
Yeah, because of the x squared. So this one, you don't have a choice. It must be, no matter what, got to be long division because of the x squared. So just a little review of the long division. Dylan, what do you think about when we're using long division?
Take away the 5 and only use the x squared.
So yeah, ignore the 5. You're looking at x squared. What do you multiply x squared by to make it 2x to the 4th?
X squared.
What kind of x squared?
2x squared.
Right. And I'm going to place in here that missing piece, the 0x squared, and then negative 10x minus 9. So he said 2x squared. And then Dylan, what do you do with that 2x squared?
Multiply it by the x squared plus 5.
And that gives you
2x to the 4th plus 10x squared.
Right. And then instead of adding, these get subtracted. So when you subtract the 2x to the 4th, the goal is to get the first term to cancel. And then bringing down, we have 2x cubed. There's not an x cubed here. So don't forget to bring that 2x cubed down. 0x squared minus 10x squared. And then I'm going to bring down the next number or term, which is negative 10x. And then you continue. So thinking again, we have an x squared. What do I multiply it by to make it 2x cubed? So Carrie, I have x squared. What do I multiply it by to make it 2x cubed?
2x.
2x. And then Carrie, when you do the multiplication, you get
2x cubed plus 0x squared plus 10x.
so plus 0x squared and then plus 10x. Remember, these get subtracted. Be really careful when you're subtracting. Everything is being subtracted. So Carrie, the 2x cubed cancels, and then you have,
Negative 10x squared minus 20x.
nice job. Make sure you've got that minus 20x because that minus sign distributes. So the 10x doesn't cancel. Instead, a negative 10x and a negative 10x gives us a minus 20x. Bringing down the last number of negative 9 and performing the division of 1 final step. Brenton, we have an x squared. What do we do to make it negative 10x squared?
Multiplied by.
Yeah, negative 10. And that gives you
Plus 10x squared, and then that's plus 50.
and he's telling me plus because when you distribute that negative through, both of those turn into a positive. So this time you have a remainder. Brenton, what is the remainder? And what else?
And
Right, so negative 20x. Don't forget about that little guy there. It's still there. It needs to be brought down because there's nothing for it to combine with. And then you get the plus 41. So when you write this solution, it has a remainder. We divided with x squared plus 5. Our quotient is 2x squared plus 2x minus 10. And then the remainder is negative 20x plus 41. You could factor a 2 out here if you wanted to. You could pull a 2 out and write it in front, but it doesn't factor any further, so it's not necessary to do that. Any questions on either form, synthetic or long division? Just be really careful with the minus sign. If you made a mistake, it's probably because like the minus sign carrying through, or you just didn't combine your like terms correctly. So yeah, Josh.
So you don't have to factor it out?
You don't have to. Correct, yes. Today we'll talk about like fully factoring everything. Good possible. I'd like you to look at your homework. Number 39 was a really special problem. So if you can pull out that homework. So today we have one final thing to kind of wrap up this section, and it's called the rational zero test. So we'll see pretty much the goal of the section is to find all the zeros of the polynomial, and the rational zero test will help us to do that. So that's the goal. Can we factor a polynomial that isn't factorable by our traditional method, which is why we have synthetic and long division. So if you look at 39, the directions of like the last group of problems may have been a little confusing, but the goal was to use the remainder theorem and either synthetic division or simply taking that number and plugging it in to all of your x values, because that's what k really represents. So that's what the remainder theorem says. That k value, part of the remainder theorem, means you can take that number and plug it in for x, or you can divide using synthetic division with that number. So you can do it either way. I'm going to use synthetic division. So k is the number you're dividing with. That's what this number is called. It's k. But it's really what x is equal to, because x is equal to k. So that's our intercept if I had a remainder of 0, or it represents a point on the graph. So we're going to try and divide with the square root of 2. Listing the coefficients, we have a 1, a 3, a negative 2, and a negative 14. It's okay that it's a square root. Keep it as a square root. Don't make it 1.41. It's as a square root, it's exact. As a decimal, it's not. So just keep it exact. What do you do first with synthetic division? Yeah, bring down the first term. And then, Colin, you're supposed to? Yeah, multiply the k value, the number inside the circle, by the number down below. So, Colin, 1 times the square root of 2 is 1 square root of 2. And then you're supposed to add them. How do you add 3 and the square root of 2? Carrie?
Just 3 plus the square.
Yeah, you just write it 3 plus the square root of 2. They're not the same type of numbers. So the only way you can physically add them is by putting a plus sign in the middle or getting a decimal. Evil decimals. No decimals. So then, Carrie, the next step would be,
Multiply square root of 2 times 2 plus the square root of 2.
right, so whatever's in the circle, you're supposed to multiply by whatever is underneath our bar here. And that means we're taking the square root of 2 times 3 plus the square root of 2. You might need to do a little scratch work on the side. So Carrie, if I multiply, we have the square root of 2 times 3.
So you get 3 times the square root of 2 plus 2.
Yeah, and then the square root of 2 times the square root of 2 is plus 2. So again, you might need to do a little scratch work to try and get it to multiply correctly. It does work out semi-nicely, Carrie, because when you add negative 2 and 3 square roots of 2 plus 2, you end up with
3 square root of 2.
3 square root of 2. These guys are the like terms. They're both numbers. They're integers. They're going to cancel. Negative 2 plus 2 cancels, leaving us just with 3 square roots of 2. So now I do it again, multiplying those two pieces. So we have the square root of 2. We're multiplying that with 3 and the square root of 2. How do you multiply that?
You should just multiply straight across. It's like they're combined.
Yeah. So multiply straight across. Really, there's a 1 in front of this square root. So 1 and 3 make 3. Colin, the square root of 2 times the square root of 2 is 2. You're multiplying straight across, as he said. So the outside pieces, the inside pieces. What is 3 times 2?
6.
6. So it really does work out nicely in the end because I end up with just a remainder of negative 8. No square roots in the problem for the remainder. So I know it looks weird because you have square roots underneath, but it still can work with synthetic division. So we would write our answer. I think this asked you to write your answer just as like f of whatever I divided with. Square root of 2 equals negative 8. That's what the remainder theorem says. So whatever you divided with is equal to your remainder. So I could go on the graph, if I could graph this in the calculator, we could find the square root of 2, and it should be equal to negative 8. That's the remainder theorem. Are there other questions from your homework you would like to go over if you have a question about? Really good problem working with the square root. Questions? So we are going to talk about the last little concept of 2.3, which is called the rational zero test. So in your packet, maybe this is page 27, I think. Yeah, page 27. be to find zeros of polynomial functions that we cannot factor by using GCF, by using perfect squares, by using AC grouping. That's the goal. So can we find all of the zeros, the x-intercepts? Can I solve the polynomial? If it can't be factored, it can't be, the GCF can't be taken out. And that's what synthetic division and long division does. So it enables us to factor with an untraditional sense of factoring, because really anything being broken down is a method of factoring. So the rational zero test helps us find a possible list of, it says roots. A root is the same thing as a zero, it's the same thing as an x-intercept. Essentially, it helps us find the answers for x by giving us a possible list of x-intercepts, a possible list of solutions. A rational number is a fraction. So we're talking about how can I find zeros that are fractional values or whole number values. The whole goal is to not use a calculator. That's the goal. Because math was created without calculators. There weren't any calculators around. They literally walked around, in my mind. They had this little chart that had all the values of the square roots on them, and they just, some math that I walked around with all those values. But there were no calculators. They did everything mentally or by using little charts. So we're not going to do all of that mentally, but it's kind of the goal. How does all of this work? Where is it coming from without relying on that little calculator? So in the first example, it wants us to list the possible zeros. So these are possible solutions to the problem. Because right now, if I look at it, there's infinite. I have no clue what the zeros are by looking at the 2x cubed negative x minus 13x plus 8. But we can get a limited amount by using this special test. So the test, the first part is 3 steps. It says to list the factors of p, which is called the constant term. So the constant term represents a p. And it says list the factors of the constant term. So what are the factors of 8? What multiplies together to be 8? That's what a factor is. Dylan, what multiplies to be 8? 4 and 2.
1 and 8.
1 and 8. So the factors of 8 would be 1, 2, 4, and 8. And my 6th grader just reviewed factors, least common, multiples, greatest common factors. They did all that in the last chapter they were just working on. So factors. Because I could have a 1 times an 8 or a negative 1 times an 8, it could be a positive or a negative option. So I could have negative 1, negative 8, positive 1, positive 8, still gets me 8. So each of these factors are actually a plus or minus, because I could have both of them be positive, both of them be negative. The second step says list the factors of q. Q is the leading coefficient. It's the number in front of the biggest power. The biggest power right here is x cubed, so q is 2. So the factors of 2, Dylan, would just be 1 and 2. And again, it's plus or minus because I could take positive 1 times positive 1, or 2, or negative 1 times negative 2. The third step now is where we get that rational part. Rational means a fraction. Any rational number can be written as a fraction. Our rational numbers are of the form p divided by q. And when we did rational functions last year, that's the form that we use for a rational function. That's a definition, p of x over q of x. So we are going to find all of the p divided by q values. So looking at my list of factors for p, I have a 1. And if I divide it by q, I would divide it by 1. And then I would take that same p value and divide it by the other factor for q. Because I'm going to list all of the possible zeros when I could take any combination of p and divide it by q. So 1 divided by 2. And then I'm going to continue that fashion, going to the next p value and dividing it by both q. So my next p value is 2, and then divided by 1. And then I have 2 divided by 2. So I'm just taking P, dividing it by each Q. So 4 divided by 1, 4 divided by 2. You only have to write the plus or minus sign once. You don't need plus or minus 1 divided by plus or minus 2. And then the last one, we have 8 and 8 over 2. So the last step, I'm going to simplify this, making sure there aren't any repeats and all the fractions are simplified, so that I get hopefully a smaller list. So 1 over 1 just simplifies to 1. 1/2 doesn't simplify. 2 over 1 is 2. 2 over 2 is 1. I already have 1 listed, I'm not going to write it again. And then we have 4 over 1, which is 4. 4 over 2 is 2. Again, I already got 2 on my list. And then I have 8 over 1, or just 8. 8 over 2 is 4. So this list represents the possible solutions to my problem. If you look at the original function, how many answers could we have? How do I know how many answers I would have? What tells me the number of answers we should have? What part of the equation would say how many x's, how many solutions, how many intercepts? Come on. The power, the largest power. So the largest power is 3. That means I should have 3 answers, 3 x-intercepts, 3 solutions, 3 factors, 3 zeros. How many do we have listed here? 10. So I have 10. Of those 10, 3 are the answers. So this list gives me a reduced list of zeros. That would work. Our goal is going to be to use these to find out which ones actually do work. So now I have 10. Of those 10, which 3 are the actual answers? And that's what the rational zero test does. So instead of me randomly just picking an x value and being like, all right, I'm going to try this x, I'm going to try this x, I at least have numbers to try to see which ones actually work. They work if I get a remainder of 0. And that's what synthetic division does. So synthetic division, anytime I use any of these numbers and I get a remainder of 0, that means I have a solution, I have an x-intercept, I have a factor. So we're going to see if we can try one of these problems, but I'm going to let you cheat a little bit because 22 years ago, 23 years ago, oh, maybe 23, I'm getting old, I wasn't allowed to cheat. We never used calculators, ever, in my math class when I was in high school. I use them a little bit in calculus, but we only use them in class on certain days. And I'm not bragging and saying I'm better. It's just that's the way the world was compared to the world is now. So if you look at the first question, you have 3 to do like this tonight. And I have specific directions. I wrote some of the directions on the board over there, but there's a whole paragraph to go along with 3 problems tonight. And you're going to do these steps here. So our goal is to find all of the zeros, all of the x-intercepts. To do this, it's a 3-part process. The first part is to list the possible zeros. That's the mathematical to support as to why my zeros are kind of being created. Where are they coming from? So we are going to list the possible rational zeros by getting P, by getting Q, and then getting a list of P divided by Q values. So again, this is my algebraic support as to I've got all these zeros to choose from. Because of these P over Q values, I can choose from this smaller list. So looking at P, P is in the back, Q is in the front. You're listing the factors of P, and you're listing the factors of Q. They all get a plus or minus every single time, because I could have a positive times a positive, a negative times a negative, and still get a positive answer. And then you're taking each P and dividing it by your Q. This gives me then a list of zeros to choose from. So if you want to simplify it as you're working, that's fine. So 1 over 1 is just 1, 1 over 2, 1 over 4. 3 over 1 becomes 3, and then 3 over 2, 3 over 4. If I already have a number written once, I wouldn't write it again. And then I have 5 over 1, 5 over 2, 5 over 4, and then finally 15, 15 over 2, 15 over 4. So I have 24 zeros up here. When I was in Trig and Pre-Calc and we did this, we would have then been given a whole sheet of paper and we would have been asked to start dividing. So I would have taken the first 0 of positive 1 and I would use synthetic division for -12, -1, 15, and I would literally divide to see if this was a 0. So you don't have to do this, I'm just kind of showing you the whole process behind it. So I would drop down the 4, multiply, get a -8, this is a -9, and I get a remainder of 6. And then I would say, darn, if I have a remainder of 6, that means the 1 isn't a 0. So then I'd have to try -1. And I would do the synthetic division, and I would hope and pray that I get a 0, because if not, then I'd have to try the next one of 1/2, or a -1/2, or 1/4, or -1/4, until I found one that worked. You have a calculator, so we are going to use the calculator to find one rational 0, and only one. So in your calculator, graph this function, and just find one 0 that's in this list. It must be in the list. I have to have a rational number. So find 1 0. You're going to see 3. I want you to just get 1 because we're going to find the other 2 algebraically. So graph it and find a 0. Colin, did you find one?
Yeah.
What'd you get?
You want the calculator? On the calculator to decimal,
Okay.
-0.97.
-0.97. What would you say that's probably supposed to be? Probably -1. I don't know what your calculator's doing. Did anybody else get -1? Yes? Okay. Your calculator's just being a little funky today. I don't know why. So we're going to use the number -1 and synthetic division to factor this 0 out of the polynomial. So synthetic division is a way of factoring. So taking the -1, which lucky me, I would have used -1 second and I would have found that it was a 0 because I would have gotten a remainder of 0. So we're going to use this -1. The original coefficients, and we're going to divide. So synthetic division. So use this 0 and synthetic division to factor it out of the polynomial. So bring down the 4, multiply. You better get a remainder of 0 if your calculator told you that it was supposed to be a 0 or an x-intercept. Colin, what is your leftover piece with the 4, -16, and 15? What does that mean?
That's what is factored.
Yeah, so what x's go back with it?
X squared, -12, or x,
And then just 15. So that's our remaining polynomial. So we factored it with the -1. Our remaining polynomial is now 4x squared minus 6x plus 15. The next part, the last part here, says factor this polynomial completely. So I'm going to take this remaining piece, and we're going to factor it completely. So my function I now have 4x squared minus 16x plus 15. We also use the negative 1, so as a factor that turns into an x plus 1. This is something we know how to factor because we have AC grouping. So factor this, taking 4 times 15, which is 60. Ugh, two numbers that multiply to be 60, but combine to be negative 16. Hannah. Nice, negative 10, negative 6. Factor out what they have in common. And then I have 2x minus 3, 2x minus 5, and then that original one I turned into a factor because we used a negative 1 to divide. That means my factor is an x plus 1. So if these are the factors, what are your 3 zeros? So my 3 zeros would be 3 halves, 5 halves, and negative 1. Questions? So we're going to try and start the next problem at the top of the page. So our goal is to use the rational zero test as an algebraic support as to why I can go into the calculator. So that's why I can use the calculator and get a 0. And then after I get that 0 from the calculator, then we use synthetic division to see if we can find the other zeros algebraically. So P and Q. Doesn't matter that P is negative, it's still plus or minus 1, plus or minus 2. So again, following the directions on the homework. So 57, you're just doing this. 67 and 69, you're listing these and then you're finding the zeros from the calculator. After you have your list, you're going to go to the calculator. Hold on, you're having a rough time. So we got this list from the calculator. We're going to find one rational zero. One number that's in the list. And just one. If it isn't from the list, you can't write it down. Anna, did you find one?
2/3.
Yeah. Is 2/3 in our list? Yeah, it's that last one. And then the last step, you have 2/3. Yes, you can use a fraction. So the warm-up had the fraction of 2/3. And we're going to use synthetic division. So I know the bell is going to ring, probably in 10 or 12 seconds. See if you can finish this problem doing the synthetic division. Your homework tonight, you got a handful of problems in the book. 3 problems, you're going to do the full process. And then the next page in your packet is a start to review for this section. So just the 1 through 5. Tomorrow we'll wrap up this section and really begin reviewing for the test on Friday.